probability? Probability is defined as, in general, the desired number of desired outcomes. I'll explain what this means. Over the total number of possible outcomes. So, what is the, if I have a coin with a heads and tails, I make a really bad looking head. Somebody who had some sort of weird deformity. Okay, heads and tails. What total possibility, how many total number of possible outcomes do I have? Two. No matter how I look at it, I can only get this one or this one. Two. So what is the probability that I'm going to get heads?
1.
It's 1 over 2, right? If I have a die, what's my total, what's the probability I'm going to get a 3? Well, there's only 1 3, and there's 6 possibilities of me getting it. But what if I say that it's what is the probability of getting a number greater than 4?
It's going to be 4 over 6.
2 over 6, because what numbers are greater than 4? The 5 and the 6, and then this. So is it starting to make sense? Now, in the book, you have a chart. And in the chart, it's because you have 2 dice. You have, as you can see, I would be a good partner with Pictionary. Okay, I have 2 dice, right? And there's all these different sorts of combinations. So I'm going to put, this is die 1, and this is die 2. Now, for die 1, I have 1, 2, 3, 4, 5, and 6. For die 2, I have 1, 2, 3, 4, 5, and 6. So even though I have a 3 here, it is not the same as this 3 here. Would you agree? And this 4 is different than this 4, and I have different numbers for both of them. So, if this is where you start getting the combinations. So you've got 1 and 1 will give you 2. This one with this 2 with this 1 would give you 3. And this one with this 2 would give you 3. And that's how you get that chart. You start filling this in, and this would give you 4. And this would give you 4. And this would give you 4. And 5 and 6 and 7 and so on. Okay? So now you know how this chart works. There's questions on the chart, or what it means or what it does for you. So, question. What is the total number of possible outcomes between 2 dice? 36, because I have 36 possible combinations, correct? So what is the probability that I'm going to get a 12, for example?
1.
I chose the wrong number. What is the probability I'm going to get a 7?
6 out of 36.
6 out of 36, because I keep going and I have 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And then 7, 8, 9, 10, 11, and 12. And if I count, you are correct, there are 6. Okay? So that means I simplify it and I have 1 over 6. Is that clear?
Yes.
Now, what happens if I want a specific type of coin? Let's say, going back to the coins, what is the probability that I'm going to get heads, tails, and heads? Question. If they are independent of each other, meaning I don't want it in this order. I just want 2 heads and a tail. What is the probability that is there going to be any difference if I tell you I threw my coin and I got a head? matter what I got before?
No.
No. So those are independent, correct? But if I want it, it's still gonna be 1/2, right? Because who cares what you got before? It's still 1 out of 2. What happens if I want it in a specific order? I want heads, heads, and tails in that order. Will it be more probable or less probable that I'm gonna get my way in the order that I want it? It's less probable because I'm adding other things into it. So how do you make it mathematically speaking? Well, what's the probability I'm gonna get heads?
100.
What's the probability I'm gonna get heads again?
100.
And what's the probability that I'm gonna get tails? So it's 1 in 8 that I'm gonna get this result. So think about Lotto, or think about the lottery in the States. How many numbers do you have to guess? Do you know?
8.
You have to guess 8 numbers, 2-digit numbers, okay? What is the probability that I'm gonna get the number in that order out of 99 for each one? It's 1 in 99 times 1 in 99 times 1 in 99, 8 times. So it's 1 in 99 to the 8th. What's the probability? Mr.
I'm trying to do it.
I know. Just put 1 in 99.
It's, I can't read that.
It's like 10.
I feel like 12. I remember 12
I'm
going
gonna
to 8 was more than the actual calculation.
How much is it? What's the
It's only 2 digits.
Is it a number?
Nine.
Guys,
No,
just
that's
give
fine.
me 1
That's fine.
over 99 to the 8. What is it? It's going to be a tiny little number. It's
It's gonna be 1.08 times 10 minus 16.
1.08 times 10 to the minus
16.
5. So there's, to the minus 16 is how many? It's 16 zeros,
Yes.
right? So it's, you have a higher probability of getting hit by lightning than you do of guessing all 8 numbers, okay? Which is why there's so much money in the pot. Because all these millions of people, even the odds are against them, just so you know. Okay, so is it understood how to get dependent events? So how about, I have an urn. An urn is that thing where you put the ashes of the loved one if they're cremated. But we're not gonna put the ashes of Aunt Clara, we're gonna put balls. We're gonna put 5 blue balls, 5 red balls, let's put 7 red balls, for a total of, and let's say 2 white ones, for a total of 14 balls total, okay? I put my hand in, and I want the probability that I'm gonna draw a blue ball, a red ball, and then another red ball without replacing it every time. So I'm gonna put my hand in, and I'm gonna take out a blue ball. What's the probability it's gonna be blue?
Wait, so isn't it BRW?
5.
No, it's
No, because I want red
Blue,
balls.
red, and red.
The white one's just a decoy,
1 in 14.
but it's in there.
5.
1
5
5
over
1
14.
The blue one, how many blues do I have?
5 over
5.
14.
So I have a 5 in 14 chance of grabbing the blue one at the beginning, okay? Now, this is where everybody gets confused, including me a couple of years ago. Not a couple, like 15 years ago. I assume that the one I take out is blue, and the one I'm keeping is blue. That's the one I'm not putting in. So what is the probability that I'm gonna get a red one now that I kept the blue
7
one
over
outside?
13.
7 over 13. Why 13?
Because
you took
we
that
have
one.
Because I pulled one out, right? And I had kept it. The next one,
6 over 12.
it's gonna be 6 over 12 because I kept that red ball, okay? And you might say, but what if it isn't a red ball? Yes, but I'm assuming it is, so I can mathematically prove what the probability would be, okay? Is that clear? Is it clear how to do this? And that, my friends, is probability in a nutshell. Peace.